context of trigonometric equations, there are three basic results that one has to take cognizance of. One is alpha is a known angle and sine theta is a moving angle. So if sine theta is sine alpha, if sine of theta is sine of alpha, what's theta in terms of alpha? The second one is if cos theta is cosine alpha, for example, if cos theta is cos 60 degrees, what is the generalized solution for theta? If tan theta is tan alpha, alpha could be 30 degrees, so say this is tan 30 degrees, what is the generalized solution for theta? Right? We are going to address these three basic results in this session. So sine theta equal to sine alpha is about sine theta minus sine alpha equal to 0, right? And that's going to be about 2 sine c minus sine d, 2 sine c minus d by 2 cos c plus d by 2 equal to 0, which gives me either sine theta minus alpha is 0, sine theta minus alpha by 2 is 0, or cos theta plus alpha by 2 is 0. Now, if sine of an angle is 0, what's that angle? From the previous section we have learned, if sine of an angle is 0, that angle must be an integral multiple of pi. So this would give me theta minus alpha by 2 equal to an integral multiple of pi. That means this in turn would give me theta equal to 2n pi plus alpha. Right? Now if cos of an angle is 0, what's that angle? That angle is supposed to be an odd multiple of pi by 2. So this is going to give me cos of theta plus alpha by 2 0 means theta plus alpha by 2 must be an odd multiple of pi by 2, right? So this 2 gets cancelled. This gives me like theta equal to 2n plus 1 pi minus alpha is what I get, right? So then, so when this number is even, I get a plus sign with alpha. When this number is odd, I get a minus sign with alpha. So if I have to combine these two, this is like theta equal to n pi plus minus 1 to power n alpha is what I get. If I have to combine these two, because realize when n is even, that is this case, when this number is even, minus 1 to power n will become plus 1. So even multiple of pi plus alpha, that's how you should read this, right? What about this case? When n is odd, that means n is this, then odd multiple of pi, and then minus 1 to power n will become minus 1. When n is odd, it will become minus 1, it will reduce to this case. So if I combine these two cases together, I get one single case, theta equal to n pi plus minus 1 to power n alpha is what I get out of it. Yes or no? So the generalized solution for sine theta equal to sine alpha is theta equal to n pi plus minus 1 to power n alpha. Now, let me look at the generalized solution for this. So n is any integer, even or odd. N even will reduce to this case, n odd will reduce to this case. Now let me look at cos theta equal to cos alpha. Cos theta equal to cos alpha is like cos theta minus cos alpha as 0. Cos c minus cos d, 2 sine d minus c by 2 sine c plus d by 2. D minus c by 2 sine c plus d by 2 is 0, which in turn gives me, if sine of alpha minus theta by 2 is 0, sine of theta minus alpha by 2 will also be 0, right? So there are two cases that will emerge clearly. Sine of theta minus alpha by 2 is 0. That means theta minus alpha by 2 must be an integral multiple of pi, right? If sine of an angle is 0, that angle must be an integral multiple of pi, or theta would be then 2n pi plus alpha is one possibility, right? What about this case? When sine of this is 0, this will give me theta plus alpha by 2 equal to once again an integral multiple of pi, and then this is going to yield 2n pi minus alpha? So there are two possibilities. When cos theta is cos alpha, theta would be either 2n pi plus alpha or 2n pi minus alpha. If I have to coalesce the two together, it's going to give me theta equal to 2n pi plus minus alpha, right? Theta equal to 2n pi plus minus alpha. So cos theta equal to cos alpha gives me theta equal to 2n pi plus minus alpha. Now tan theta equal to tan alpha. So I convert into sin theta by cos theta equal to sin alpha by cos alpha, right? Or sin theta cos alpha minus sin alpha cos theta is 0. And then this gives me like a sin A cos B minus sin B cos A is 0. Sin of theta minus alpha is 0. Or theta minus alpha must be an integral multiple of pi, or theta must be an integral multiple of pi plus alpha. Yes or no? Right? So if tan theta is tan alpha, theta is integral multiple of pi plus alpha. And by the way, you know, cos theta equal to cos alpha gives me this solution, but this is also equivalent to saying sec theta equal to sec alpha, which will give me the same solution. Sin theta equal to sin alpha is the same as saying cosec theta equal to cosec alpha. Cosec alpha, which will give me this as the solution. So sin theta equal to sin alpha gives me theta equal to n pi plus minus 1 to power n alpha. Cos theta equal to cos alpha gives me theta equal to 2n pi plus minus alpha. Tan theta equal to tan alpha, which is equivalent to cot theta equal to cot alpha, which gives me theta equal to an integral multiple of pi plus alpha. So we have a basic framework. So the kind of results that we've learned: when sin theta is 0, theta is an integral multiple of pi. When cos theta is 0, theta is an odd multiple of pi by 2. When sin theta is sin alpha, theta equal to n pi plus minus 1 to power n alpha. When cos theta is cos alpha, theta equal to 2n pi plus minus alpha. When tan theta is tan alpha, theta is n pi plus alpha. Yes or no? I'm going to add a little more in a little while.